resultant acceleration. Resultant acceleration. Right. Then when object is in uniform is in circular motion with uniform velocity. Circular motion in uniform velocity. There is no tangential acceleration. There is no tangential acceleration. But there is a radial acceleration component. Radial acceleration component. But there is a radial acceleration component. Therefore, when object is in object having a non-uniform velocity, it having both acceleration components. It having both acceleration components. It having both acceleration components. Therefore, we have take the resultant of these acceleration components. When object having a uniform velocity, while in a circular motion, only the resultant acceleration is AR, only the resultant acceleration is AR. Right up, not done this one. True. This one. This is only the radial acceleration. Yeah, we know only radial acceleration. But when object doesn't have a velocity as constant, when it increase, there are also a AR, AT. AR is always AR while when it started the circular motion, there is a AR component in every time, right? But when it having non-uniform velocity, it having a AT also. Okay. Then if it doesn't have a uniform velocity, we have to take all the components of, we have to take the AR and AT, then we have to take the acceleration result, AR, right? Write down. When there is, when a particle doesn't have in a uniform velocity, doesn't have any uniform velocity, it may having, it may having radial acceleration and radial acceleration and tangential acceleration. Radial acceleration and tangential acceleration. They are perpendicular to each other. They are perpendicular to each other. Because of that, to calculate the acceleration, we have to take, to calculate the acceleration, we have to take radial acceleration. We have to take the resultant acceleration. We have to take the resultant acceleration. Capital A, capital R. A, capital R. Okay. This one, when I draw like this, the AR in this direction, AR in this direction, right? Right now, AR equals to the AT square plus AR square, the root, right? Then the tan alpha equals to the, we can draw this one, polygon, not parallel. Therefore, we can get tan alpha as AR over AT. AR over AT. Okay, right on. Alpha equals tan inverse AR over AT. Okay. Write down this one. Then write down example. When object having a circular motion, with radius 2 meter, and its angular velocity, radius 2 meter, and its angular velocity alpha equals to 6 rad s minus 2, 6 rad s minus 2. Find the resultant acceleration. Find the resultant acceleration when find the resultant acceleration when it having a tangential velocity, tangential velocity 5 ms minus 1, 5 ms minus 1, right? In that case, we have find the AR, capital AR. For that, we have take AT, tangential acceleration, AR, both of them. Then we have to get the vector summation of that, the resultant of that. Okay, fine. In this case, we have to find AR and AT. First, we can find the AT, right? Why? We know AT equals R alpha, the radius and everything. We know AT means R means 2 meter, alpha means 6. Therefore, 12 ms minus 2. AT equals that one. And we can take what is the AR? AR. We can take AR equals, in this case, the radial axis, the tangential velocity is 5 ms minus 1. Therefore, AR equals V square over R. Therefore, AR equals V square means 5 square over R means 2. 25 over 2. That means 12.5 ms minus 2. 12.5 ms minus 2. The resultant is AT along the tangential direction. AT radial component is on the radial direction. The resultant is AR, that's on this direction. So AR equals 12.5 ms minus 1 2. This one is 12 ms minus 2. We have to take the resultant. We have to take the resultant, right? What is the resultant? AR equals AT square plus AR square whole root 2. Right? That's the way. Okay. Therefore, we can take 12 square and 12.5 square. 12 square and 12.5 square. 17.33. Yes. The answer 13.25. Therefore, 17.33 ms minus 2. Right. The angle can be take the resultant of the angle. We have to take the angle also. Tan alpha equals 12 over 12.5. Alpha equals tan inverse 12 over 12.5. Right. The angle is 43 degrees 49. Yes, this one. Okay. Write down the topic. centripetal force. Write down the topic. Centripetal force. What mean by centripetal force? Centripetal force. Write down the topic. Centripetal force. What mean by centripetal force? We discussed there is an acceleration component. There is acceleration component along the radial direction. In every time when we started the circular motion, there is acceleration component. Why? The radial acceleration component we are getting because the change of the direction of the tangential velocity. When the tangential velocity changes, why change? When it in uniform velocity isn't changing. Yes, why? Because when it in uniform velocity, the velocity component, the direction of the velocity component always change. That's why we are telling there when there is a radial component, it when the start of the in every time there is a radial acceleration component, right? In every time there is a radial acceleration component, right? Therefore, if there is a radial acceleration component, when we start the circular motion, there is a radial acceleration component. Therefore, when it start the AR, when it having the AR, when it having the AR, there is a force that's called centripetal force. Why? If a mass having acceleration on the direction, we can take the radial direction. There is a force. Why? F equals ma. F equals ma. Right? Write down. Write down. When an object moves, along a circular path, there an acceleration on the object. There is acceleration on the object towards the center of. There's acceleration on the object towards the center of circle. It is known as centripetal acceleration. Centripetal acceleration. Centripetal acceleration. Centripetal acceleration. According to the Newton second law, in brackets, F equals ma, there is a force, which acts on an object towards the, according to Newton's second law, F equals ma, there is a force which acts on an object towards the towards the center of circle, center of circle is known as is known as is known as centripetal force. Centripetal force is known as centripetal force. இலங்க ரூல் இல்லையா? It is a external force. It is a external force which have to supply externally. Which have to supply externally. It is an external force which have to supply externally. Which have to supply externally. Example. Example. Example galiyanda. When an object is connected. When an object is connected to a string and rotated in a circular path, rotated in a circular path as the centripetal force, provided by the string. Let's talk about that. When we are connected the object with a string and we are rotating it. Therefore, the centripetal force provided by the tension of the string. It's applied externally. The tension is the external force. This is the centripetal force. Okay. When we take the circular bend with the vehicle, what is the centripetal force? What is the centripetal force? Centripetal force is the what? Friction force. When we are rotating around the sun or the moon rotating around the earth, what is the centripetal force? It is a circular motion. What is centripetal force? It is a gravitation force. The centripetal force always supply external to the object. Right? Okay. Draw it. Write down the example 2. The motion occur when vehicle take a circular bend. The centripetal force is a friction force. Centripetal force is a friction force. When an object is motion, this is circular bend, which having a radius r. It is going like this. It's going like this. What is the frictional force? What is the centripetal force? Centripetal force is a frictional force, right? F is a frictional force, right? It is the centripetal force, right? It is the centripetal force. The centripetal force is given externally to the object. Given externally to the object. Write down. Okay. Draw this one. Draw this one. Okay. Okay. This the centripetal is strong and string. When it rotating, the centripetal force provided by tension. Tension. Right? To the center, there is a centripetal force. To the center, there is a centripetal force. Right. What is the centripetal force provided by this? The friction. The friction acting on the friction F equals to the centripetal force. Centripetal force. Right. Like that. Okay. When we are taking when we are taking like this, when we are move in a bus, we are what is the friction what is the centripetal force? It's also a frictional force or the reaction force which are coming from the supports, right? Like that. Okay. Then write down. Then write down another point. When an object, when an object, when an object moves on a moves on a circle path, circle path, circular path. If a centripetal force, if a centripetal force get disappeared, at instant, the object moves, the object moves, the object moves, the direction in which, the direction in which the tangential velocity, the tangential velocity occurred. The tangential velocity occurred. Let's take this example. when we rotate using a string, right? While moving, we cut the string, right? While moving, we cut the string. Therefore, it's moving along this direction, along this direction. Why? The centripetal this when the centripetal force disappear, it's move along the tangential velocity direction, right? It's moving like this direction, right? Write down it. Write down this one. Moving with the tangential velocity direction. Moving to the tangential velocity direction. Write down another point. Write down another point. Centripetal force. Centripetal force is always, draw this one and write down. Centripetal force is always, centripetal force is always directed towards the center, directed towards the center, directed towards the center, but the tangential velocity, tangential velocity every is always tangential, is always tangential, but there is no displacement, there is no displacement, there is no displacement along the radius, along the radius, while it moving the, while it moving the circular motion, circular motion, circular motion. Because of that, because of that, there is no, there is no, because of that, there is no work done by, work done by centripetal force. Work done by centripetal force. There is no work done by centripetal force.
Sir, there is no
Okay. Write down the problem. Write down the problem. There is no work done by a centripetal force, right? You have to memorize that there is no displacement. Because of that, there is no work done. Why? Work done is W equals to the Fx. W equals to the Fx. Because when there is no displacement along the center direction, there is no work done. There is no work done. Okay? Right. Write down an object. Example, an object having a weight 100 grams and a weight 100 grams and a weight 100 grams is connected to the, is connected to the string of, string of 1 meter long, 1 meter long, and it rotated, and it rotated in a horizontal circle, horizontal circle of speed 120 rpm. 120 rpm. Now, object having a 100 meter, 100 grams, it's connected to the string 100 grams. It's connected to the string and it's rotating the horizontal surface like this, right? Horizontal surface. Number one. Number one. Find the angular velocity. Find the angular velocity. It's given the n. We have to take the angular velocity. Find the angular velocity. Number two. Find the tangential speed. Find the tangential speed. Tangential speed. Number three. Find the radial acceleration. Find the radial acceleration. Number four. Find the period of motion. Find the period of motion. Find the period of motion. Right. Number one, angular acceleration, omega. Number two, P. Number three, AR. Number four, period of time, T. Find it. We have to take first of all omega. Omega equals what? Omega equals 2 pi n. 2 pi n means 120 and RPS. We have to divide into 60. 4 pi. Okay, for pi already s minus 2. Number one. Number two, when we substitute this one, 4 into 3.14. Okay. When we substitute that one, we can get 12.56 RAD S minus 2. Then what is the P? P equals R omega. Yes, your answer is correct. R equals what? 1 meter. Omega equals 12.56. That means 12.56 ms minus 2. Number 3. What is the AR? What is the AR? AR equals to the V square over R. AR equals to the V square over R. That means we can apply V means what? Or we can take omega square. Right? AR equals 4 pi square. That means 16 pi square. It's near to the 160 ms minus 2. We can take the 5 square as the 10. Right. Find the period of motion. Okay, we have to take what's that? Number 4. T equals 2 pi over omega. Omega we know the 4 pi, 2 pi, 4 pi. Omega equals 0.5 seconds. That's okay. Right.